Aloha. Our first video is going to correspond to pages 7 and 8 in your notes. So this is the top of the page. It looks like, how about these lines? What are their slopes and the equation? So for the first graph and the second graph, it's kind of hard to tell just because of the quality print. But the line that we're looking at is this blue one right here that's going across. So what's the equation of that line? If you want to go back and watch our video from last week, you can on slopes. Otherwise, we're going to review it right now too. So this is a horizontal line. So if Mario was taking a stroll across here, Mario moves from left to right. He's not going uphill, he's not going downhill, he's going straight across. And that means that it is a zero slope. And the letter that we use for slope is M. So you could say that M is 0. And we also talked about the equation of that line. If you look at every single point in this line, this is going to be like negative, 5, 4, negative 3, 4, negative 1, 4, 0, 4, 2, 4, 4, 4, 8, 4, 9, 4, 10, 4. If you look at every single, y value on that, the y value is stuck at 4. And that would be your equation of that line. Y equals 4. Moving over to the right one, I will use green to make it Christmassy. Whoops, this is the line that we're looking at, that we're trying to identify. So this one is supposed to be a vertical line here. So if you're looking for the slope of a vertical line, we said that if you try to put Mario on top of here, here's Mario. Can he move to the right? No, he can't. If he moved off of this line, he's going to fall straight down forever. That slope is called undefined. As for the equation, well, it's the same thing but flippy-floppy. If you look at this equation, this is the point negative 3, 0. This is the point negative 3, 1, negative 3, 2, negative 3, 4, negative 3, 6, negative 3, 10, negative 3, negative 5. If you look at every single x value is stuck at negative 3. I'm sorry, this should not be an equal sign. This should be like a colon. There we go. So there is your equation. X is stuck at negative 3. Doesn't matter what y is. X is always negative 3 going up and down. Moving on to the next one. So here we got a car rental. I think you have to be 25 or so to rent a car in this state, so it's going to be a while for you guys to do that. But suppose it costs $25 to rent a car and 10 cents per, and we don't use kilometers, we use miles, but this one uses kilometers. So 10 cents per kilometer to drive, and we want to create a graph. So this first data point right here is saying that if you go and rent that car and you don't even leave the lot, you go 0 miles, you're still going to get charged a $25 base fee. So no matter what, you charge 25 bucks. And then you're charged every kilometer after that 10 cents. So if you're thinking about going 1 kilometer, that's going to charge you 10 cents. So if you went 2 kilometers, that would be 20 cents. 3 kilometers, 30 cents. 4 kilometers, 50 cents. 6, 67, 78, 89, 90. And then 10 kilometers would charge you $1. 90 cents plus 10 cents is $1. So going 10 kilometers is going to charge you $1 more than this. So that'd be 26. So mathematically, how I got there was, I was saying I'm charged 10 cents per kilometer, and I went 10 kilometers, and then I have to add on my base fee as well of 25 bucks. So the formula, you could say, for this, the cost is always going to be 10 cents times the number of miles plus your rental fee of 25 bucks. But from here, if we go another 10 kilometers, we know that we're going to get charged another $1. So this formula, the way that the chart is written, is really nice. Every 10 kilometers is $1. So I can fill it in real fast. So part A was to find the rate of change. Well, the rate of change is exactly what this thing is right here. It's 10 cents per 1 kilometer. Or if you want to look at it like this, every 10 kilometers is $1. So you could say either one of those things. It's $1 per kilometer. Or I'm sorry, per 10 kilometers. So either way you want to look at that is perfectly fine. So, next thing we gotta do is get a graph of this. I'm gonna switch over to my favorite color, blue. And now this is in my way. Get out of here. Looking at setting this one up. So our x-axis is going to be the distance we go. We got to go up to 50. I think if I skip every 2, if I make every one 5, so like this is 5, this would be 10, 15, 20, 25, 30, so 20, 35, 40, 45, 50, that will work. And then for here we can choose to try to go up to 30 as our max, or otherwise we can do a break in the graph. I'm just going to keep it simple for now and just go all the way up. So I think what I'll do is, I think I'll just go up by 3s. Every 3 will be 10. So this is like 3 1/3, that's kind of weird. 10, 20, and 30. So if I'm graphing this, the first spot is at 0.25, which is right in the middle. After 10, I'm at 26, 27, 28, 29, and 30. So if I were to try to draw the line that goes through this, it's going to look something like that. So what is the value on the y-axis? Okay, the y-axis is going to be this guy right here, and that's the value 0.25. What does that relate? Well, if you go 0 miles, you get charged 25 bucks, or kilometers if you don't drive it off the lot. 0 kilometers is going to charge you still 25 bucks. If you paid the same fee for the car rental, but you paid more per kilometer, what would the graph look like? Well, if you're getting charged more, it's going to be increasing. You're going to get charged more per mile. It's going to have a steeper slope. All right, flip to the next page, page 8. So this is the really important stuff right here. So for this part, we are looking at identifying the slope. So now there's kind of 2 ways that we can go about doing this. There's the graphical way we can do it using the graph. Otherwise, there is a formula. So write this formula down if you are a formula person. Well, you should write it down anyways. Put it up there in the corner. The slope can be identified as the y2 minus y1 over x2 minus x1. So got a lot to dig about there. And just remember that this is the same thing as rise over run. So let's first do it graphically, and then we'll come back to the formula and make sense of it. So if I look at this first problem, I got the 0.22 and I got the 0.4, -1. Again, I always work my way left to right. Mario runs left to right. So if I'm going from this point to that point, I'm calling this one 0.1 and this is 0.2. So how do I get from one point to the other? I'm going to be going down, and here you can count the blocks really nice. 1, 2, 3. So I'm going down 3, and I'm going over 1, 2. So down is the negative direction, to the right is the positive direction. My slope should be -3 over 2. So that is the super nice way of doing it. The other way you can do it is you can look at it like this, using a formula. Now how the formula relates to it is, if this is 0.1, x1 represents the x-coordinate of the first point. y1 is the y-coordinate of the first point. This would be the x-coordinate of the second point, and this is the y-coordinate of the second point. So these little sub 2's and sub 1's, that's just telling you which point you're looking at. 0.1 x, 0.1 y, 0.2 x, 0.2 y. And once you have them labeled like this, then you can go ahead and fill in the formula. So I'll try to squeeze it in right here. So it says, take this y value of the second point, which is -1, subtract the y value of the first point, which is 2, divide that by the x value of the second point, 4, subtract the x value of the first point 2. -1 minus 2 is like you owe me $1 and you owe me another $2, you owe me $3. 4 minus 2 is 2. Look at that, it's the same thing. You should get the same thing. And just another quick note is that this line is slanting downwards as you go to the right, so you should get a negative slope out of this. So if you mess up your negative sign somewhere, take a note that you should be getting a negative right there. The other thing you can do is, I could have called this one 0.2 and this one 0.1, and these values would have been swapped, but you still will get a -3/2. You'll actually get 3/-2, but the position of the negative sign doesn't matter. The negative sign can be on top, can be on the bottom, or can be out front. The negative just means that, yes, your line is going down as you move to the right. Another kind of funky thing is, if you're thinking about the rise over the run in this form, you are actually moving backwards. You could rise 3, and then a run of -2 is actually going left. So you do end up going to a different point if you go that way. Rise 3, run -2 to the left. So either one of these are going to be the same thing, one negative sign going down. All right, so your mission is to work on this problem and work on problem number 2 down here. And my hint for number 2 is, if the formula is confusing you, just draw a graph. Here is 7, -2. Here is 5, 6. Try to find the slope of that line. Ooh, what do you notice about the slope right away? Should be negative. And then see if you can work out these ones. And then once you finish with that, then we'll move on to video number 2.